welcome also from my side to everybody to join us in this webinar today. And as Helena has mentioned, my name is Aderman Soster. I'm the DAS Division Manager in HEMI Controls since 2015. And just a moment. I cannot scroll the presentation. Oh, okay, sorry. And just a short story about the company, the group. In 1984, Technopine starts to manufacture special equipment for the snow business. And this means that from more than 30 years in our group, we have technology and we are leader for what concern the water mist and water mist application. In 2011, Technopine established HEMI Controls as an independent company for what concern the application of water mist in dust abatement, odor abatement, firefighting, and evaporation. In 2017, HEMI Controls started to have cooperation with ANSA Engineering, which is our partner and distributor for the Scandinavian area, so means Sweden, Norway, Denmark, and Finland. So let's start and have a short look for about the why is dust suppression important. There are several points about the importance of dust abatement. First of all, the health and safety is very well known and recognized from decades actually that the dust abatement is very important, especially for the health of the people, especially for the employees are working on the demolition site, on the quarry or mining. Dust, especially the silica dust or maybe asbestos or something else, are responsible for many issues with the respiratory problem, and also important, it's the lung cancer. Risk of accident. There are several ways where it's very important to abate the dust. For example, a very big quarry, whether there's a big dumper or big shovel, the dust is so huge that time to time there are also really big accidents between the trucks are moving material in the quarries, for example. This dust, of course, it's a problem for who lives close to those areas, like, for example, the quarries or the demolition or the recycling area. So we want to also to avoid to have any conflict with the neighbors are living close to those facilities. Dust is also a very big problem for what concern the cost in maintenance and cleaning of the equipment and the machine that are operating. For example, the truck, the dumpers, the hopper, the old belt of the conveyor. And of course, now in many countries, there are a lot of restrictions and laws that are trying to make a regulation on what is the available and allowable dust in the air that we breathe. Recently, also in the United States, from I guess last September, October, they cut the 50% of the airborne dust that was allowed in the air. So let's see also what is the technology behind an efficient dust suppression. Okay, it's very well known that the small droplets are the best way to collide and to be combined with the dust in order to bring the dust to the ground and to maintain calm into the ground itself. And the ground will remain also a little bit moister, so the dust will remain there. The main methods that we have available on the market to atomize water or fluid are, first of all, the pressure, to use compressed air, centrifugal system, electrostatic system, and even also ultrasonic, like for example, the aerosol machine. After long experience that we have had in the market, we decided the only way just for our application to have a very good efficiency in the atomization of water is to use high pressure. High pressure means that we have the fluid, like for example, the water that we use, that is forces, okay, through a very small nozzles, okay? After the nozzles, it emerges like a stream, okay, at a very high speed, because we have to consider that if we have high pressure in the nozzles and outside in the atmosphere we have 0 bar, okay, this very high dissipation of energy creates this fragmentation of the stream in some parts, and as far as we can go after the nozzle, this will be in small droplet. This picture is very significant in my opinion, because you can see that the water stream that we have is totally fragmented in very, very small droplet, okay? So the source of energy, the main source of energy is the fluid pressure itself that is converted into a momentum and the fluid exits from the nozzles. Which are the factors that are affecting this spray? Of course, the orifice diameter. As much smaller the orifice, as much higher will be the fragmentation that we have. Of course, also the atmosphere, the environmental where we spray. I mean, if there is a windy condition, if there is humidity, relative humidity, the temperature. And also the relative velocity between the fluid, the stream of fluid that we have, and the air that is in the atmosphere. Why we choose to use just pressure atomization for dust suppression? There are two main points. The first one is the cost, because just to raise the pressure of water, it's very simple, and it's the cost is very low. We can raise up to maybe 100 bar with the standard piston pump, and the cost is not so high. And also the efficiency. There is a very strict correlation between the cost and also the efficiency, because higher is the pressure, finer is the mist. So with very, very, let me say, simple system, we can have a very high efficiency in water atomization that is converted into very high efficiency in dust suppression. Let's talk about also why we choose also pressure atomization. There is a strict correlation also between the droplet size and the dimension of the particle of dust that we want to abate. Here, for example, you can see in this drawing, a big droplet of water is not able to catch small particle of dust. The particle of dust will sleeps around the drop of water. On the opposite side, the correct dimension of the droplet will collide with the same dimension of dust. So this is really, really important. And so if we consider our experience, all the dust generating point, they have a quite large spectrum of dimension of particle. Means that we can measure between, let me say, 10 microns up to 100, 200 microns, the dimensions of the dust that we want to abate. So we have to be able, with our equipment, to create the same droplet size. Means that we have to create between 10 microns up to maybe 500 microns, the droplet size. That's the usual dimension for dust suppression. Another important aspect of the dimension of the droplet, if, for example, if you consider the water truck that are wetting the ground on the streets, on the roads, or maybe also on the quarries, they are just only spraying water from a back down bar, or maybe people are using also standard big heavy sprinkler that are used also in irrigation, or maybe also in the soccer field to maintain wet the soccer field. This is okay to create a lot of water in the ground, but a lot of water means pond, means also that there is a huge consumption of water for nothing. If we consider to use 1 liter of water and we are able to spread this liter of water in small droplet, if we consider 1 millimeter in diameter, we can cover around 6 square meter. But if we can downgrade the dimension of the droplet size of the 1 liter in 10 micron, we can cover 600 square meter. So it's very easy to understand that if we want to cover a very huge surface with droplet, the main way is just, the most important way is just to divide in small droplet, because we can save a lot of water. In this picture, you see one machine installed in a wood chip recycling area. This machine is working outside. Outside means that the equipment is under environmental condition, especially rain and of course wind. Wind is a very strong effect on the dust abatement because small droplets, okay, they are colliding in a very high efficiency way, the small particle of dust, but they are, let me say, more wind dependent. And large droplets are less wind dependent, but of course they have also a lower dust binding efficiency. So it's not easy to find the correct balance between the dimension of water and the position of the equipment, the water consumption. So let's see how we can keep the balance, okay? The full control of water mist is made by adjusting the nozzles. I mean, at the beginning, if you remember, we talked about the orifice of the nozzle. So the orifice play a very important role in the droplet dimension. So the choice of the nozzles, the possibility to change also the water flow, and also the possibility to change the spraying distance, okay? Here we have an example of one of our machine where we can play. Okay, with the throwing distance, the machine can operate with the full speed of the turbine, with also a medium speed of the turbine, or maybe just only with the pressure of the pump. And we can play also with the water flow, changing the water flow in the machine itself. So we have different ways just to manage the throwing distance, the quality of the droplet, and that's really important with our equipment because we want to have the large spectrum of droplet to cover all the possible possibilities that we have in the field. So let's talk about the technology, about the efficient dust suppression. We spoke about the nozzle. Okay, in EMI controls, we develop in our machine a special nozzle head that is inside of the turbine, of the cone of the turbine. Why this one? Because consider that from the engine, from the turbine itself, from the propeller, we have a laminar flow. And this means that we want to have the possibility to give to the droplet the same laminar flow because we want to manage as much as possible the direction of the plume that we create with our spray stream. The nozzle that you can see here, they have also a ceramic insert. This means that you can also use industrial water with some surfactant, with some also salinity inside, and there will be no any more problem with the corrosion of the nozzle itself. As you can see here also, we have two pipes that are feeding the nozzle head, and we have two separate circuits. So means that we can operate with one circuit, with the other one, or both together. So we can choose also three different water flow consumption. I mentioned also about the variable throwing distance that we have with one machine that we manufacture, where we can change the speed of the rotation of the impeller. And of course, why we choose also to have the head internally of the turbine? Because in this way, we give immediately the energy that is coming from the impeller to the droplet. So the droplets are coming out from the turbine. They have, let me say, a less dependence from the wind, the lateral wind. Of course, if we have a very huge machine like the V22, that is the biggest that we manufacture, and we have a very throwing distance, very high throwing distance. We reach up maybe 80, 90 meters from the machine. This means that we want to cover a very huge area, but also a very huge volume of air. So we have increased also with an external ring the machine. Okay. Another very important aspect of the equipment that we manufacture is the design of the rotor blades. We started more or less in the company 30 years ago in manufacturing turbine for the snow business. And it's very important to use the correct material and also the correct design. Why the material? Mostly of the impeller that are in the market are with the blades made in plastic. Plastic is okay because it's less expensive, of course, but there are several disadvantages. Like, for example, the thermal excursion. If we operate between, let me say, -20 up to +30, you can imagine that the plastic has a very high thermal excursion. So after those cyclic of hot and cold, the plastic can affect a sort of fragile construction. So it can happen that you can have also breakage on the impeller itself. And so we move slowly up to an aluminum cast alloy that is very, very good in efficiency for the laminar flow. It's very resistant. It's the weight of the blades, it's very low. So we have a very high efficiency also in the rotation of the impeller using less power. We have to talk about also the drawing of the design of the blades. At the beginning, the design was like a square, okay? That's a square rectangular blades. Now we have this shape that it's like the one that you have on the rotor of the engine of the airplane. Why this one? Because in order to have a very good laminar flow, we want to maintain the pressure that we generate with the rotation of the blades constant to the air that we push. And in order thus to have this one, due to the fact that the pressure decrease from the axle of the rotor till the external part close to the turbine, if we have this design, we maintain constant the pressure on the air. So the flow is very, very laminar. That's quite important. It's really important in order to have the possibility to maintain full control on the pressure of the air that we generate, on the spray stream that we generate. Okay, after talk about the efficiency on dust and the machine that we manufacture with the technology, we have to check something about the sub-zero conditions. What is happening if we have to make dust abatement under 0 Celsius degrees? Okay, because of course there are several companies that they have also a problem with the dust also during the winter time. For example, in the Scandinavia area or in Russia, all the area where there is freezing temperature in the winter time, they have for sure also dust during the winter. The solutions that are available on the market are dust turbine with the heating function, or maybe to use also the snow guns, or maybe to think about to use a hybrid dust turbine. Dust turbine with a heating function are just a standard machine where there are some heating strips or heating system just to prevent damages on the machine itself. But with this equipment, it's possible to operate till, let me say, -10 Celsius degrees. And if we have to go down below -10, we need to have for sure an intelligent heating system, because if we are operating at -20, -25, when you switch on the machine has to be already heated, has to be ready to work. The automatic drainage also has to be very sophisticated, because we have to drain all the water from the nozzle, from the hydraulic circuit, from the pump, in order to prevent any damage. And of course, at this low temperature, the only way just to be able to abate dust is to create a crystal of snow. And the only way to make crystal of snow is to use, together with water, also compressed air. So the only way is just to think about to use a snow gun. That is the one that is manufactured just to make snow. But why is not suitable to use a snow gun to make dust suppression? In the ski slope, we have to manufacture to produce dry snow, because of the fact that the skier, they want to ski on dry snow. Okay, so the snow blower is built just to maintain the quality of dry snow along a very high spectrum of temperature and relative humidity. And they are able to make the same dry snow between 0 down to -25. The compressor that is used to press air for making the snow in some of the machine is not possible to switch off during the summer period. And those compressors are specifically designed to operate below zero, not up to 20 or 25. And consider also that the season in the snow business, it's very short. And on the ski slope, they want to have the possibility to produce as much as possible cubic meter of snow in a very short time. So the water consumption with the snow blower is very, very high, too high for the dust suppression business. Consider that a standard snow blower in 1 hour in certain condition can produce between 50 to 60 cubic meter of snow, sorry. Those machines are also not designed to operate in the harsh environment. Those machines are built just to stay in the forest, not in quarries, in mining, in the steel industry, in the slag, for example, recycling area. And also the total running time per year. Consider that in maybe 4 years, a snow gun can work for maybe 1,000 hours, something like that, maybe 2,000. And in the dust business, in 4 years, you can have also 15,000 hours. So the components, the mechanic, the construction is totally different. So that's why we decided to move to design an hybrid dust turbine that it's able to operate in the summer period, let me say up to plus 40, even to minus 25 during the freezing period. And this machine, of course, is built for the dust business, so it's very robust, but has also the same suitable solution for making snow. I mean that we have the software and the capacity to maintain heated machine during the freezing period. We have also the possibility to make snow also close to 0 degrees till minus 25, but with the quality of wet snow. That is the one that we want to have to be able to collect the dust, the airborne dust. And the machine is able also to switch automatically between the hot and the cold temperature by itself, switching off the compressor and also the heating system and the automatic drainage. What is behind the production of snow? We have the nucleator nozzle that are special nozzle, those one, where inside there is a special insert where we mix water together with air. And in this way, we create a sort of air bubble covered by water that we call nucleo. This nucleo starts to make the first flow snake, okay, the first snowflake. The quadrijet that are close to the nucleator create the water mist, and the snowflake collects the mist growing itself. So the snowflake will grow. And due to the throwing distance, we, let me say, simulate the fact that the snowflake is falling from sky. Okay, and why we want to use snow? Because snow has a special structure. The density is totally different from ice. Snow, it's an open structure. It's a solid, but it's an open structure with also humidity. So it's the only way just to collect also dust, airborne dust, when you are in the freezing temperature, like minus 20 or minus 25. Ice, it's a solid. So it's if you don't have the possibility to make snow, and if you spray just only water, big droplet water, that it's like to spray, it's like to fire, let me say, needle against the dust. It's not possible to collect the dust. So here we can summarize just a little bit the different solution we have if we are working below minus 10. Of course, with the standard machine, it's not possible because we have just only a heating system. With the snow gun and the hybrid machine, this is possible. The snow crystal is possible to create a snow crystal just only with the snow gun and with the hybrid machine. But the only machine are suitable for those conditions, also for hard condition, is an hybrid machine. which we have the possibility also to switch automatically off the compressor. It's very important to have multiple spray options and flow. And of course, with the hybrid machine that is fully designed for dust abatement, we can manage also the flow to have a very low flow for dust abatement. The automatic heating is present just only on the snow gun and on the hybrid, and also the automatic drainage. That is very, very important. Here we have an example. During the presentation, you saw probably, you remember some picture with some port. Those are coming from some application we have done in Russia. Here we have, for example, the port of Nakotka. That is very in the very far east, close to Vladivostok. There are several huge, big coal terminal over there with the train that are downloading the coal, stacker reclaimer, and we have several applications like this one, where the problem was to create snow to collect the airborne dust, but also to cover the stockpile of coal with a thin film of snow, just to avoid that the wind that is blowing that area can blow out the dust over the city. We have fixed installation with several machines, and that we can manage with our software from the remote office of the terminal. And here, in cooperation with our partner that we have in Russia, they build this special wagon that is moving on the railway, where also the stacker reclaimer is moving. So this system, for example, contains two big water tanks, because we have two blower, two big water tanks, 60 cubic meter each, and the whole wagon is heated for operating till minus 30 Celsius degrees. So this is a very, very interesting, let me say, project that we have working in Russia. Okay, from my side, the presentation, let me say, is finished. Now I'm available for some question and answer that maybe someone has for me.
Let me see here if we have any questions. Here, Alverman, we have, if we can use, I think you quickly touched on that in your presentation, but if we have particles, on site in the water, for instance, can you take water from a dam, or how is that sorted?
Yes, sure, because on our equipment is equipped with a special filter inside the machine, because of course, very often, the end user, the customer, they don't have the possibility to supply to the system, let me say, potable water, fresh water. So we can use also water coming from reservoir, from tank, from dam, because we have inside stainless steel filters that are very, very easy to clean and accessible. On our installation, like the one that you saw in Port of Nakotka, we have also created pumping station with also filter station. So it's not a problem. But for sure, the machine, also the standalone machine, they can operate also with the industrial water or water pumped from the ground.